Hello, welcome to the lesson on morphological transformations. Since we are running out of time, I thought of recording this lesson. So, morphological transformations are important class of basic image processing techniques. They contain these simple operations that usually work on binary images. For example, when we segment an image, we make a binary output, and maybe there are noisy components. And what we want to do in these morphological transformations is to get rid of these noisy patches. So these are typical morphological operations, and there are many more. We will see what these morphological operations are in this. So morphological operations formally are simple set-based operations on non-zero structures in a usually binary image. And these are applicable to grayscale images also, but in this lesson we will only look at binary images. So we can construct operations sensitive to shapes in the input image. Basic operations are erosion and dilation, and using this erosion and dilation we can come up with many other operations like opening, closing, morphological gradient, top hat, black hat, and so on. So in these operations there is this input image, the regular binary image that we take as the input image, and there is a structuring element. So that's a small image that defines how the morphological operation spread given a non-zero element in the image. Then we get an output binary image after the morphological operation. Okay, to understand these things, we need to define some set operations. So if we consider a set in z squared integers, which are pixel coordinates xy, and we define xy as w, a set A is like w is an element of A, something like that. So we can define the complement, w is not in A, and a set of B pixels satisfying a particular condition, we write as B equals W given that condition. For example, A prime or the complement of A is W such that W does not belong to A. Okay, then we have the union C equals A union B, then the intersection C equals A intersection B, and the difference A minus B equals W such that W is an element of A but not an element of B, and so on. So we can view the pictorially like this. So these are the two sets A and B. So here is the union, and here is the intersection. Here is the complement of A prime, and A minus B. These are simple set operations. We need two additional operations called reflection and translation in this morphological operation. So therefore B hat or the reflection is W such that W is minus B for all B in B. So you see that set B gets reflected at the origin due to this operation. And then there is translation of set A by Z equals Zx, Zy denoted by Az. So in this case, Az means all elements C such that C equals A plus Z for all A in A. Okay, here they are pictorially, so you can see the translation, which is quite easy by Z, and the reflection. So the original image was like this. You remember set B, and now it has been reflected in this image. Okay, then what are dilation and erosion? The operation of dilation and erosion are fundamental to morphological image processing. Many of the algorithms are based on these ones. So before understanding what dilation is in a theoretical perspective, we will look at a dilation operation. So in this case, we have been given an image. This is the image, and here is the structuring element, and we have to slide the structuring element across the image and see what is the overlap. But similar to convolution, we have to reflect the sliding window or the structuring element first. Now you can see there is a well-defined center or an origin in the image. So we have to know where it is given any location of this structuring element. Okay. So now we move this structuring element onto the image, and we know here is the center. Now, is there an overlap between the black pixels in the image, actually they are white, and the structuring element white pixels, which are shaded in light blue? There is no overlap. So for this corresponding location, in the result, we put 0. So I will not put anything in this location right now because it is 0. Alright. Then we move the structuring element, and when we move the structuring element, is there any overlap between the elements with 1? There is no overlap. So for this location also, we do not write anything, or it is 0. The next one we move. Then when we move, you can see there is an overlap. So therefore this we have to shade or make it 1. Then you move once again, you can see there is an overlap there also, and overlaps in that row further. After that we go to the next row, and there also we start moving, and when the location is here, there would be an overlap, so we have to shade that, and here there would be an overlap, we have to shade that, and here there would be an overlap, we have to shade that. And in this case, there would be an overlap obviously here, and no more overlaps anymore. So therefore you can see the result of dilation of this particular image using this simple structuring element turned out to be like this. So now we can see it actually did this operation called dilation. Now what do you understand by dilation? So if you go to the eye doctor, he will put this dilation liquid into your eyes to be able to enlarge your the iris and see inside the eye. So there is a sort of enlarging. So you can see the white areas of the image, or the one areas of the image, have been enlarged or dilated as the dilation operation defines it. Okay, so that's dilation. The erosion is sort of an opposite. In the erosion, the structuring element is not reflected in this case, has to fully overlap. The ones of the structuring element in the erosion operation will have to fully overlap with the image. Now here is the center. So where would it fully overlap? Actually, now if we keep this here, there is no full overlap at all. Here, there is no full overlap at all. So like so, we had seen there is full overlap. So full overlap happens at locations such as, now here there will be full overlap in this location. So we have to shade that, since there is full overlap there, and there is no full overlap here, and there is full overlap there. I think that is all. So here the answer is this. So you can see it is like erosion. Now think about soil erosion. There is this area in the image, and we have eroded that, eaten it out, erosion. Okay, now we'll formally look at this thing. So dilation is an operation that grows or thickens objects in binary images. Dilation translates the origin of the structuring element throughout the domain of images and checks whether it overlaps with one value pixels. The output of the image is 1 at each location of the origin of the structuring element. If the structuring element overlaps at least one valued pixel in the input image. So this is the operation that we carried out. So in mathematical terms, the dilation operation, we denote that by a circled cross, results in all Z locations where the reflected and translated structuring element. So this is the image. A is the image, B is the structuring element. Structuring element overlaps as a union, non-zero union, non-zero intersection with it. Whenever it intersects, we take that origin and mark it as 1. Okay, so this is the intersection. So dilation is actually commutative, associative, and as a result, we can represent two dilation operations as one of dilation operations, like convolution. Okay, so using the same thing, if you want a 5 by 5 dilation, 5 by 5 structuring element, okay, so I think that small, this B, which is 5 by 5 dilation, this one. We can represent that as dilation with two vectors, sort of. So therefore, you can see the amount of computation can be reduced using this idea. So what is erosion? Erosion shrinks or thins. In a binary image, the output of the erosion has the value 1 at each location of the origin of the structuring element, such that the structuring element overlaps only one valued pixels of the input image. So it has to fully overlap with those. So therefore, we can define this A minus circled. A is the image, B is the structuring element, all locations of Ez such that there is no reflection, you can see here. Translate the elements of B. Intersection with A prime complement of A is non-zero. So with complement of A, B does not overlap at all. So then all locations that fulfill this requirement come into this erosion output. Okay. So here are some examples. So you can see the image and the structuring element. It's a rectangular structuring element. When you run dilation, you can see the image is dilated, so the white side is expanded. If you run erosion, you can see the parts that are smaller than the structuring elements one value are eroded out, and even these rectangles have been eroded out in the erosion. Okay. So in OpenCV and Python, how do you do it? So you open the image. Okay, you load your CV, NumPy, and then open the image. So move left is that image, and then we define a kernel. So once 3 by 3 once, and then to run that you have CV.dilate, CV.dilate, and then you can display it. And this is a simple way of getting dilation working. So similarly, you can do erosion also by replacing this word dilation by erosion. Okay. Then by combining these operations, we can do opening and closing. So opening is just another name for erosion followed by dilation. Erosion followed by dilation. So it is useful in removing noise and opening gaps connected by thin structures. So you can see when you erode, thin structures disappear. When you dilate, the existing structures will enlarge. So thin structures will go, they will not come back. So therefore, we can now write opening the empty circle. Empty circle is first we do erosion. Then after that we do dilation. Okay. Actually, it can be written in this fashion also. So take some time to think about this one, what opening is. So closing is the reverse of opening. It is dilation followed by erosion. So it is useful in closing small holes inside foreground objects or small black points in objects. It can also close small gaps. So we use the darken the circle to signify closing, and you can see closing operation is first we do dilation and then we do erosion. A is the image here and B is the structure element. Okay, so how do you do these things in Python? So same thing, you open the image and then you use the morphological EX function, and there you have to write what CV dot. Actually here I have used black hat. Sorry, so you can use dilation, erosion, closing, opening, and all these things I guess in this opening and closing for sure. Okay, here are some examples of opening and closing. So original image is this. So here you can see there's a thin structure. So if you use this kind of a structuring element and close it, so it's closed. As the name suggests, closed. and erosion, the stream structure just disappears. Okay, so um, now how do we produce these outputs, for example? So I will describe one, and then the rest you can think about at home. Now there's this image, so I think you know that it is Abraham Lincoln's binary image. How do you produce the outline? One thing that you can do is you can dilate by an element, structuring element like this, so that it dilates in all four directions. Structuring element like that, dilation is also all four directions, and then you can subtract the original from the dilated version so that you get the outline. So think about the other operations, the top hat operation, then the black hat operation, and so on. And go home and think about these things. Mm. So as an assessment, what you can do is, now in MATLAB there is an image called rice.png. It has rice grains. And you can see an example in MATLAB called BW Morphological Operations. They have done many things like rice grain counting. So you can try to do that in Python, and if you do that in Python, uh, it will be a nice exercise. Let me see if I can show you some of these operations. For example, now here the black cat operation I can run. I am doing something here to make the image large because I am running them on very small images. So this is the original image, and then here is the black cat version. So if you want to do something like opening, morph open, and then you can do opening. Why it is not working? Okay, the dilation is used that was. Okay, so that's good enough. Then there's another file where I wrote those. Unfortunately, things didn't work right now. Okay, so I think that is good enough. So, okay, thank you.